All right. In our past note-taking sessions, we've talked about igneous rocks. We talked about intrusive and extrusive, and you have those all in your notes. Today, we're going to talk about sedimentary rocks. And what I'm going to ask you to do is put these into your notebook. Date it to the day that you took the notes. Title it 3.3 Sedimentary Rocks. You're going to have to pardon me for some of the little pixelations that are going on, but for the most part, just anything that's highlighted. But sedimentary rocks, we've talked, they're made of small pieces, cemented together in layers. Those are those key words. Three different ways that they could form. One is that they get transported by rivers. These sediments get transported by rivers and they settle at the bottom, and then over time they build up in layers and they press together, and over a very long period of time minerals crystallize and they hold it together like cement. The second way that they could happen are plants and shells. Well, they form layers. When they die, they fall to the bottom, they fall to the ground, they sink to the bottom, and they just form layer after layer after layer and layer. Limestone, which was rock sample number 14, I think, in our kits, was made this way with shells of the sea creatures over many, 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 many millions of years. They form that way. And then the third way is sometimes the minerals themselves dissolve into a liquid, and then sometime over time they reform into something else. This rock salt is an example of an example of that. So when you look at sedimentary rocks, they do show how they are affected by wind and water. So with the action of the wind and water on sedimentary rocks, remember they're formed because wind and water have moved them and layered them. But something called cross-bedding, this would right down here would be an example of cross-bedding down this bottom picture. Maybe my head's in the way. I'll unlock it and I'll move it. This is cross-bedding, where it looks like you've got crisscrossing. Wind has moved it and has allowed it to form in different layers. Ripples, that one is just like what it sounds like. You can kind of look like it was water ripples there. At one point, water was above this. And then mud cracks is just like the picture indicates. It looks like it is cracks in the mud. So that would be an example of how wind and water actually affect it. We move on to the next section, metamorphic rocks. We've talked about in class, metamorphism is the changing of one thing to another. I kind of equate it to caterpillars, cocoons, or chrysalis, and turning into a butterfly. Over time, you take an igneous rock or a sedimentary rock or even a metamorphic rock, and you add heat, which is indicated in the flames, and pressure is this pressure gauge. Over time, it'll change it into a different metamorphic rock. For example, shale, which was one of the ones that we talked about in class in our kits. If we add heat and pressure to it, it will change to gneiss, or excuse me, gneiss. This is the whole series, a whole family of how heat and pressure can change a rock. It can take the rock shale, which is a sedimentary rock, and turn it into slate, being metamorphic. Actually, I think shale is metamorphic as well. Metamorphic rock, disregard the where it says sedimentary, but it's metamorphic. Heat and pressure adds it to it. It changes it to slate. Slate then changes it to heat and pressure changes it to phyllite, and then more heat and pressure changes it to schist, and then over time more pressure turns it to gneiss. So you can kind of see the whole progression there. Now, metamorphic rocks change can happen over a large area like a mountain range with lots of heat and pressure of the mountains changing rocks, or it can be just a small area where, like magma in this picture here, scoots up and heats areas around the magma to a point where it doesn't melt the rock, but it changes it to something else. When metamorphic rocks get pushed together, there are two main types, something called foliated and something that's called non-foliated. Foliated, you can kind of see that these minerals are formed in parallel wavy layers or bands. Um, Non-foliated just look like a hodgepodge of different crystals or bands of minerals banded, not in layers. Um, and then we get our little review. I'd like you to try this review when you are done with all your notes. You can look through your notes to see if it helps you, but um, I'd like you to go and pause this video, try to answer them, um, and then when you're done pausing the slide, um, take it, and then when you're done taking it, then you can look at the answers. I'm going to give you about 2 seconds, 5 seconds to stop and pause it, but the first answer um, is C, igneous. The second one, rock cycle, shows how rocks continually, D, change over time. Which kind of rocks forms when molten rock cools? Those would be igneous rocks. And the existing rock can change from one type to another because of a pressure. That's the metamorphic part. Pieces of rock that settle and form pieces just indicates sedimentary rocks. Looking at the rock cycle here, this was that image that you have that I've shared with you a couple times, where loose minerals develop into rock. These are the sediments. They change into rocks at B, the rock forming stage. Number 2, where are sand and other small particles forming from rock? That's going to be A, the breaking apart part, the weathering and erosion. That's what they make. And then where is magma developing into a rock? That one is going to be D, in the cooling part, not the melting part. Don't get caught up in thinking it's magma developing into rock, because magma is already melted. It cools and goes into that. So, and then more questions. Molten rock is forming where? That's where C. Number 4, it's the melting part. And where are heat and pressure changing solid rock into another type of rock? That's metamorphism. That's going to be in part 3, the heat and pressure area. And according to the diagram, what can happen to sedimentary rocks? Let's see, they become sedimentary or metamorphic rocks. They can, and then number 7, how can you change the diagram to show that igneous rocks can become magma? Again, C. It already has an arrow showing this, so you don't need to change it at all. And that's it. So hopefully you added those into your notes. You can pause the video. You can go back in the video and watch it. This is about 8 minutes, and that's where I'm going to stop. So if you have questions, ask me in class.